we're going to talk about in Chapter 7, which is ratios, is dilations. And the reason is to do a dilation, you need a scale factor. So let's take a review of transformations in general, because we have to remember the notation. So if you remember a transformation like translation, which means moving up and down or left and right, a rotation, or a reflection, starts with you take the x and the y, and then you draw an arrow, and then you say what to do to the x and the y. So let's say I had a triangle whose three corners were at 1, 3, 2, 6. Looks very much like a thing. And -1, -5. Okay, let's say those are the three corners of my triangle. And I had a translation, which means we're going to move up and down, left and right, but we're going to keep the shape pointing in the same direction. And I'm going to move the shape up 2 and, right 2 and down 4. Okay, because remember, x's go left and right, y's go up and down. Think about a coordinate plane. Here's y's and here's x's. The x's are moving left and right, the y's are moving up and down. All right, so I could move it right 2 and down 4 after I graph it, or I can say the new ordered pairs are 1 plus 2, or 3, and 3 minus 4, -1, 4, 2, and 1, -9. And then I would graph that, and it would be a triangle that's moved to right 2 and down 4. So, and then remember for reflections, those when to reflect across the x-axis. If I'm going to reflect across the x-axis, I'm going to take y and multiply by -1. And if I'm going to reflect across the y-axis, I'm going to take x and multiply by -1, and then y would stay the same. All right, so that's just a quick review from back in Chapter 1 about transformation notation and reflections and translations. So let's go back and look at dilations. Dilations make things get bigger and smaller, or smaller, okay? It doesn't move it, just makes it bigger or smaller, okay? So in my transformation notation, again, I have a comma b and the arrow. Now, k is the scale factor, okay? It's how much it's going to get bigger or smaller. So if k is a fraction, the shape's going to get smaller. If k is a whole number, the shape's going to get bigger, okay? So if for instance, if my scale factor is 1/2, instead of this point being at 7, 7, it's going to now be at 3 1/2, 3 1/2. So my shape is going to be down here, and then like 2, 1. It's going to be here, and then 2 1/2, 3. Oops, got my 3 1/2, like there. So can you kind of see the new shape forming? So my tennis racket's going to kind of look like that. It's going to shrink down. All right. For this shape, if I'm going to graph the image of ABC after a dilation with a scale factor of 2, that tells me the shape gets bigger, and then I want to prove that ABC is similar, or A prime, B prime, C prime is similar to ABC. So the first thing I'm going to do is multiply by a scale factor of 2. So that's going to be, B prime is going to be 0, because 0 times 2 is 0, and 2 times 1 is 2. So it's going to be at 0, 2. Let me do that maybe in red so you can see it better. So B prime would be here. A prime would be 4, 6, which would be there. And C prime would be at 6, 0. So my new triangle would be there. Okay? Now, to figure out if it's similar, I've got to check to see the ratios are the same, and the only way to check is to say that the lengths of the sides have the same ratio, and the only way to find the lengths of the sides is to use the distance formula. So to find AB, okay, I do big giant square root of AB is 2, 3, and 0, 1. So it's going to be 2 minus 0 squared plus 3 minus 1 squared. So that's 4 plus 4, or square root of 8. And then AB, A prime, B prime, again is at 0, 2, and 4, 6. So that's going to be big giant square root of 4 minus 2 squared plus 6 minus 2 squared. So that's going to be the square root of 16 plus 16, square root of 32. So to reduce those, the square root of 8 is 2 square root of 2, because it's 4 times 2, right? 8 is 4 times 2. And the square root of 32 is 4 square root of 2, because 16 times 2. So I've got 4 square root of 2 over 2 square root of 2. And if I reduce those fractions, the square root of 2's cancel, and 4 over 2 is 2. Okay, and then I have to go through that for all of them, for B prime, C prime, and BC, A prime, C prime, and AC. So if I do BC, it's 3 minus 0 is 3, and 0 minus 1 is negative 1, and they're both squared. So that's 9 plus 1 is 10. So BC is a square root of 10. B prime, C prime would be big giant square root. 6 minus 0 is 6 squared. And 0 minus 2 is negative 2 squared. So I get 36 plus 4, and that's square root of 40. Okay? Which is, so BC is the square root of 10, and B prime C prime is 2 square root of 10. So again, if I cancel square root of 10 divided by square root of 10 is 1, so that's 2 over 1, or 2. Okay, now so take a second and do A prime C prime. So we see that here's the AC and A prime C prime, and so we can see that the result is that the two triangles are similar because all the ratios of all the sides are the same, 2, 2, and 2. Okay, so the last thing we need to do is look at a dilation to make it bigger or smaller on a coordinate plane. So if we're given that GFH is similar to GEJ, and we want to find the scale factor, and we want to find what this point is, okay? Well, the scale factor would be whatever, if they're similar, we only have to really do one side, so I would do GJ over GH, okay? GJ is 24, GH is 15, because they're horizontal, right? So I don't have to worry about using the distance formula, because I can just count. This is at 24, 0. This is at 15, 0. So without really doing any calculations, I can get the scale factor. Both of those are divisible by 3, so that's 8 over 5. Okay? And that scale factor should hold for E, G, and FG. So I'm going to do GE, which is 16, over GF, which I don't know. Oh, not a 0, an X. Okay? But I know that it has to have a scale factor of 8 over 5. So then it's just a matter of cross multiplying and solving. So I get 8x is equal to 80. So x is 10. So I know that F must be located at 0, 10. Because it's over 0, up 10. Okay? All right. And that's it for dilations. And we'll do the homework tomorrow. And our test, it looks like it's going to be on Friday.